Hi, my name is Amit Nande and I work with Prolim. I lead the simulation portfolio team from Prolim. I take this opportunity to share my experience of working with the various organizations in achieving the reduced cost and time with the optimal engineering in their product development phase. So let's take examples of different industries. Like if you look at the automotive industry, that is specifically the engine team. If you go and ask any engineer to design a gasket, then he will have a question in his mind that what hole location and what size of the hole I have to consider. Then the same thing goes with the aerodynamics team as well. So to get the best aerodynamic performing design, what taper or what twist angle or what height I have to consider to get the best aerodynamic performance out of this design. And then for the oil and gas industries, they have to set up the platform to extract oil, right? So what orientation of platform will give us the best extraction of the oil? And then if you go and ask a thermal engineer who is designing the PCB and casing of the computer, he'll have questions like what to what size of fins and air vents I have to consider, where where to place them, and where to place the fan, and what the ideal size of the heat sink should be. And then again, if you go with the CFD team and then ask for designing a pipe, then he will have a question like what shape and flow rate I have to consider to get the best design. Then again, the same goes with marine industry as well. If the engineer is designing the shape of hull, then he has to, you know, uh, find the best design, right? So he'll have a question like what size and shape of hull I have to consider for better hydrodynamic performance of the ship. So these are the typical questions which our engineers will be having in their day-to-day life. So do you think how is it for you to answer these questions today? Would it help if this process was simpler and faster? That means if there is a technology which helps you to answer all of these questions with a minimal intervention of the engineer. Let's see how can we answer these kind of questions. Let's take an example of this computer casing wherein the engineer has to design this casing by considering all the parameters of these air vents and the fins and then the heat sink and the fan. So he'll he'll have to check the different configuration of placing these vents with different positions, and the same goes with air vents also with respect to shape and also the size and the position, and also he has to check with the performance with respect to different position of the fan for the better convection of the heat from the casing to the environment. So ultimately, if he has to do it manually, then at the end of the day, max he will end up with maybe 10 or max by 20, let's say 25 iterations he will do, and then out of 25 he'll select one which is the best design according to him. But the design space exploration solution of SimCenter will help you to answer all these questions and then gets you the best design out of your baseline design. So if you look at the graph, each dot talks about one design modification has been done. So uh, you can evaluate a number of uh, designs in this particular study. It has reached almost 200 evaluations. So in this, there are some feasible designs and then infeasible designs as well. So if you compare this with the baseline design, this is how it looks like. There is a 51% reduction in mass in the improved design, and then 25% cooling improvement in the overall performance. So this is how design space exploration of SimCenter from Siemens will not only help you to minimize the weight, but also it will help you to increase the performance as well. Then comes the what is the current way of doing or traditional process of finding the best design. So the traditional process is most of the steps that has to be carried out manually. So you have to define the objects, then you have to simplify the model for better convergence, and then you have to select the algorithm. There are many algorithms available, and then you have to select them one by one if the results are not met as expected. And then you have to fine tune the algorithm, that is the parameters of the algorithm to meet the desired results, and then you will have to solve it, and then you will interpret the results. If there is a deviation in predicted and actual designs, then again you have to come back to the model, and then again simplify the model further down, and then select a different algorithm, and then fine tune different parameters, and then again reconduct the search, and then post process results. Again, if there is a deviation between predicted and actual, then again you will have to redo the same process again and again and again until you get the predicted and actual match to each other. So if you look at the overall process, this is so cumbersome, right? And also because of this manual process, these can introduce so many errors also. So and it require this process or this approach requires the expertise of optimization. He has to have so many number of years of experience in optimization, then only he'll be able to select the right algorithm, and he'll be able to play with the right parameters of the algorithm to fine tune. Then this process requires a lot of iterations to get the best design out of your baseline design, resulting in very costly, I mean to say, the process, since it consumes a lot of time, uh, the entire product development becomes very costly, which makes the product costlier. Then again, it needs the expertise level of uh, information, and then because of the manual process there will be some errors which will be introduced during the process as well. So this approach of traditional process for finding the best design delivers the limited innovation. So as I said, it is getting you the best design within a limited space, and only the optimization experts can handle this, right? And also it takes a lot of time to get the best design. If you compare this with the modern process of SimCenter heats, then almost many of the tedious processes have been removed, which are made as automated one in the heats. So here you just have uh, three processes. That is, one thing is you will define the objective constraints and variables. Once it is done, then the heats will search for the best design automatically based on the parameters you have set it for, and then finally you will post process results. So you also can see the design feasibility in terms of the manufacturing, that is design robustness and sensitivity analysis. So if you look at the overall time you can save is almost more than 50%, right? So if you are saving the development time, then of course it is leading to the cost saving also, which makes the product competitive in terms of the pricing as well. So with the help of modern process of SimCenter Heats, you can discover better designs faster within a stipulated time. There are a number of case studies are available with respect to all these industries. So with the help of SimCenter simulation portfolio of Heats, uh, uh, with the help of SimCenter portfolio of simulation, you can find the success in getting the best design uh, with very less cost and with very less time. So here what you can see that you are not only reducing the weight of the design, and you are not only increasing the performance, but also you are reducing the overall cost of the product and the time to market. Thank you so much for watching. Please feel free to reach out to me if you want to know more about this. You can drop a mail to me on amit.nandi@program.com, or else you can call me up on 916-450-4590. Thank you so much. Have a nice day.